This is George Edward Allen Jr. He was a scientist and researched a lot for NASA. He was actually a managing scientist for NASA that research about the rockets. He also invented 8 of the current half-liter that exists today. George's version of the resistor isn't the one we use today. The resistor we use today in all of our electrical products was upgraded version that Otis Buckling invented. But what is the resistor? It is a resistance in a circuit that is reducing the electricity to a level so that circuit can survive. If the resistor didn't exist, it wouldn't be possible to create a circuit because the other components and the cable will burn up. Here is a resistor in a circuit diagram. It works this way. In a circuit schematic, it works this way. The power is coming from the battery and then goes like this into the resistor and then comes out more or less powerful, so the circuit can survive and all the components like the lamp here, LED, it can survive so it doesn't blow up. But if we hadn't had resistor, it would look like this. And when the power comes out from the battery, the cable will burn up or the lamp will be destroyed. The resistor is a really important component in all of our electrical products today. The last thing you need to find out about the resistor is that it measures in ohm. Yeah. You can use the resistor on different levels of power. You choose the level of power by testing how much the circuit can hold without getting destroyed. If you want to find the right resistance, there is a way to count the resistance, and you do that this way. Here's a color scheme that shows how much the different colors is on the resistor. So you can count it in an equation, so you're getting the right resistance for a special circuit. Here's a real-life resistor. You can't see the colors here, but I'll say what color it is. You always start to put the color gold or silver at the last, and then you should start with the color on the other end, that is yellow. And the yellow is worth 4. So you put the 4 here, and then you look on the second color, and that is purple, that is 7. And then you put the 7 right here. And the color that is besides the gold and silver that you shall take last is red. And that is the multiplier. And you look here is 100. So you shall multiply these two colors with the multiplier. And all that is 4,700. And that is the original value. But you can't count on the original value because the resistor has some tolerance, and that means that it always. Oh fuck! And that means that the original value, 4,700, isn't the right value all the time. It's switching a lot. So the thing you need to do is to find out what the last color is on the resistor, and that is on this one gold. And that is 5%. So now what you need to do is take 5% of 4,700. And you do that like this. You take 4,700 divided by 100, and that is 47. And then you take 47 multiplied by 5, and that is 235. And 5% of 4,700 is then 235. The thing you need to do now is to take 4,700 and then adding 235, and that is 4,935. And then the next thing you need to do is take 4,700 minus 235, and that is 4,465. And then you get the tolerance, that is 4,935 to 4,465. Tolerance was these numbers. And these numbers, this is the minimal power that the resistance can make, and that is the maximum power. So the power is switching between those two all the time. So you can also be like 4,500.
I'm going to talk about coil today. which is spule in Swedish. It works like this. The power generates so much power. We say this like 5 volts or something. It goes to the resistor, and there it gets a new value, and then it continues to the coil, which is like, let's say, like this pen. There is a little yard of metal here, but it's going to be copper. Yeah. There it's yarded like this, and then when it has come down here, you will get a frequency value out of this, and which is going to the lamp after that. The coil works a bit like this. If there are many yards in this coil, you will get a lot or a big frequency. If there are less, like we can say there maybe it's 3. Okay, there is a lot more, but you will get lower frequency from the coil. Coils is constructed regular with a thin line wounded around, let's say, a piece of iron here, and then it goes around this piece of iron and then continues out. That is the whole point of coils. But it can always, or it can also be wounded just in air, so you don't have the piece of iron in the middle. Many people say that the iron piece is better, but you can always do the air piece too. If there are high frequencies at the coil here, in the coil, the power will have a really hard time to get through the coil. So the power will be less, more or less smaller, if I can say so. If the coil even have a very high inductance, the power will be very in trouble to get past the coil. So high inductance at the coil and the high frequency will slow the power down. If there are high frequencies at the coil here, in the coil, the power will have a really hard time to get through the coil. So the power will be less, more or less smaller, if I can say so. If the coil even have a very high inductance, the power will be very in trouble to get past the coil. So high inductance at the coil and the high frequency will slow the power down. The more laps a coil have, and the closer the laps are sitting together, decides how big the inductance is going to be in the coil. The reactance is measured in ohm and is designed by X formulas. When the power through a coil, through this one, is exceeding the magnetic field, is also exceeding around the leader, which is always here. Yes, sure.